And now, from beyond our dimension, this is the JeffMara podcast. Here's Jeff.
My guest is Dr. Gerard van Belle, Director of Science at the Lowell Observatory. He's here to discuss the latest in the search for life in Mars and more. Dr. van Belle, thank you for joining us and welcome.
Thanks, Jeff. Good to be here.
Well, tell us a little bit about your history and how you got into astronomy. Was it anything like the movie Contact?
So it's not quite like that. I just always had a long interest in astronomy and parents who took me to the local library a lot. And growing up in Seattle, there's a lot of aerospace stuff in the libraries because of Boeing. And I really got into it and went off to college thinking that nobody actually gets a job doing such a thing. And so I went and did what I thought was, the smart thing, which was a pre-engineering course. But along the way, took one and then many astronomy courses and fell into that and got accepted into graduate school. And so I figured, well, let's see how long I can make this work. And 30 years later, it's still mostly working.
Well, if we get to Mars, how did it become a mostly dry planet?
Yeah, so Mars is thought to have been warmer and wetter in the geologic past. So, 1 billion, 2 billion, 3 billion years ago. And in many ways, probably a lot like the much earlier Earth of that time. And the problem is that Mars is smaller. It's about half the size of Earth. And so it leaks. The atmosphere will essentially leak away. This is one of the reasons why here on Earth we have a similar thing for at least the lightest molecules and atoms. It's very hard to find helium. And helium is a very light molecule, and it will basically escape off the top of the atmosphere. And so the only place we find helium right now is from subsurface caverns that can be tapped for that. And it's very hard to find, actually. And so Mars is the similar sort of thing, but with pretty much every bit of gas that's in this atmosphere. And so its atmospheric density is about 1,000 times less than the Earth.
It's amazing that you mentioned helium because a few years ago, I went to the party store to try to fill up some balloons, and they were out of helium, and now I know why.
And, using heliums for balloons is a terrible waste of what is actually a pretty precious resource. They're fun, and we all, of course, suck on them and do the high-pitched voice thing afterwards. But it really should be the sort of thing that we conserve a bit more.
If life did exist on Mars, how many millions, if not billions of years ago in the past would it have happened?
So it would have been there when the conditions were appropriate for it, which is to say warmer and wetter. We don't have an exact pinpoint on that as far as, we have not yet found definitive evidence for life on Mars yet. But the interesting thing about that is that this is an ongoing pursuit, is to see, could we find, say, fossils of life, or maybe even current, say, subsurface life that, you could envision a scenario where life evolved on the surface initially in this, much more benign environment that was warmer and wetter. But then as things changed, the life evolved and moved underground. Here on Earth, we find quite a bit of life pretty far underground. And in many ways, we are taking things we find here on Earth and kind of projecting that and, working by analogy right now with what we think is going on with Mars. In a similar sense with that, what we see here on Earth was that when conditions were even just beginning to be favorable with the distant past, very soon after the Earth formed. We got very simple life pretty early on here at Earth. And so, under the guess, and it's really kind of a guess because we have a sample of exactly one, under the guess that, when conditions are favorable, you will get life, then if with Mars, we expect that there was conditions back there that were favorable, then maybe at least simple life formed right away back then. But it's really one of those things where we have to go and look and see and actually gather that evidence. And this is what's going on in the space program right now.
I guess what I'm trying to determine is if life existed on Mars 1 billion years ago, Would that be enough time for all of the evidence of it to be destroyed through the geologic changes?
So certainly the expectation is that that's not the case, and this is what is actually guiding some of the currently the U.S. and European space exploration on the Martian surface right now. So, for example, we have the Perseverance rover that is just kind of zooming around Mars right now, and not only is it have cameras and drills and little chemistry labs to do things, but it's also collecting samples and drilling into samples and laying them out on the surface to be collected and returned at some point in the near future over the next few years with a mission called Mars Sample Return. And the idea is that, potentially you could have microscopic evidence for life in those samples, and that it's going to be detectable, but you'll need, an Earth-sized laboratory for that. It's not one of these little miniature labs that is currently on board the rover that could actually make that detection. So that's the whole point behind bringing a sample back, is to try and find what is evidence that has not been erased over the ensuing eons.
I'm glad you brought that up, because I was going to ask, is the benefit of sending humans really worth it versus sending the rovers there?
Yeah. So for the exploration job, the way I've heard it characterized from a geologist is that it is a real boon to have these rovers there to be doing things, but the rovers do in a month what a human can do in a few hours, in terms of being able to look at something, make a judgment, pick up a rock, take a sample, assess it, determine if it needs further investigation, that kind of thing. The rovers are great, but they're still kind of doing our work for us at arm's length, and it's a lot like looking through a straw in terms of what you can actually do, compared to if you had a person there, a scientist there that was actually a trained geologist.
How long does it take to transfer data between Mars and the Earth?
It's a few minutes. It depends exactly on the orientation of the planets, where they are in their orbits. Sometimes we're very close, and sometimes, say, Mars is on the other side of the sun and from us. But we're talking on the order of minutes of light transfer time. But that that can really slow things down in terms of a decision loop. You certainly can't operate stuff in real time. Imagine trying to play Fortnite where, your decision between targeting and pulling a trigger is, a few minutes.
Right.
It would be a mess.
Is there methane gas on Mars?
That is a very interesting question. So this is actually a story that I've been keeping my eye on for some time. And the motivation here is that it's thought that potentially methane could be associated with biological processes. So, basically cow farts, the simple thing. But it could also be other things. There could be subsurface deposits that just volcanically get released. And so already back 20 years ago, a fellow named Mike Muma started to claim that he had made detections of methane on Mars. And and methane, by the way, is very interesting in the sense that there are sources, like I just discussed, of ways you can get methane, both biotic and abiotic. But then there are sinks. There are ways that the methane gets destroyed, principally through either combining with, say, the surface, the dust and the regolith in the surface, or through ultraviolet radiation, where the sunlight will break it apart. And so if you have methane, it usually goes away after a while. So if you see methane, it's been replenished in some way. And so, is that biotic or abiotic?
Wow.
And so these detections were made for remote sensing from telescopes in Hawaii, for example. And the question was were they solid detections? They were pretty tenuous. There actually was a orbiter called the Trace gas orbiter that was sent to Mars to try and, in a more direct sense, map this out and sense this. And the launch of that spacecraft was in 2016. It got there in 2018, has been operating ever since, and they've detected no methane. And so it's a curious thing. It's like, have there just not been any releases since it was first detected back in 2003, or were the 2003 detections spurious? It remains a interesting question because, again, this is one of these very interesting pages in the mystery book of trying to detect life is, can you come up with a unique thing called a biosignature? And can you detect it? And can you then connect it to something that is biological, that is producing it? And so we have that for Mars. We actually have that for planets around other stars, where we're talking about how do you find biosignatures and what are unfalsifiable biosignatures, where if you see something, you're like, aha, that's life. And this is hard to do.
That leads us into the NASA's announcement not too long ago.
Mm-hmm.
Did they say they found biosignatures or potential biosignatures?
They said they found potential biosignatures. And so they're being very careful about their language here. It's a potential biosignature, something that could have been biological in origin, but could also be maybe produced from non-biological sources. And so in this case, with Perseverance on Mars, as it's doing its work in Jezero crater, it's gone to this place called Chelyava Falls, and there was one sample, so it's finding things that it thinks are interesting. Maybe there are some rocks that look different than the rest, and the rover can actually drill holes into these rocks and look beneath the surface of these rocks, and even do a spectral analysis where you can actually take the dust that comes out of these drills and do an analysis that tells you what materials are composing that dust. And in this case, they found a couple of very interesting minerals. The vivinite and the gregite are things that we find here on Earth in places like peat bogs and other places where there's decaying organic matter. So, is that a biosignature? Well, maybe, because you can also produce these things other ways. But the catch is that the other ways involve, say, high temperatures or very acidic conditions. And in that area on Mars, neither of those other extremes are expected to either be there or have been there in that area. And so if the other ways to produce these things don't seem likely, then maybe you're back to the biological source. And so it's potentially a biosignature, but you got to be real careful with these things because of not wanting to come up with a false positive.
What type of biosignatures would be conclusive that there was life?
Yeah. That's the problem, is that we're still trying to figure out in the scientific community what would be kind of a unequivocal biosignature, either for true remote sensing for things with other planets around other stars, or even something on Mars where we have a robot right there, and short of a handwritten note saying Kilroy was here, what is absolute evidence for that? And it's still one of those things where the science community tries to be very careful about not overstating things in this regard, because it's going to be an important discovery, and I think it actually is likely to happen, but people want to be really sure about that. And there have been kind of things that have fizzled in the past. And one of the things that is on my mind is, 30 years ago when I was a graduate student, there was a big announcement about the Martian meteorite. And this was the Alvin Hills 84001 meteorite that they thought had evidence of biological structures in there. And so this was a rock that they found out on the plains of Antarctica. It's actually a common and rather easy way to find meteorites, because on these ice sheets of Antarctica, the only rocks that are on top are the ones that came from the sky. And so you can find meteorites just by picking them up off of the ice sheet there. And so they found this one, and not only was it a meteorite that had come out of space and fallen onto Antarctica, but you can actually do a mineralogical analysis, and you can actually determine, oh, this one actually came from Mars. So on the order of, what is it, about 20 million years ago, there was probably another big meteorite that hit Mars and knocked loose some rocks back into space. And they wandered around in the solar system for about 20 million years. And they then happened to fall on Earth. And so it's basically the poor man's sample return. The problem there is that the chain of custody is such that you don't know if the rock got other things from Earth itself into it, or what happened en route. So we really want to do a sample return where we know where the rocks came from. But at least this way, this gives us a kind of like I said, the poor man's way of getting a Mars sample return going. Could
they even be contaminated just from the ice itself?
Yes, that's right. And so that's a worry. But with that Alvin Hills meteorite that they found, what they did is they drilled into it, and they found. So in this case, it wasn't a biosignature based on, say, minerals or the chemistry, but actually they found structures. The electron scanning microscope found very, very small things that at least some of the researchers ascribed to nanobacteria. So very, very tiny bacteria, which actually was itself at the time very controversial because those things they found were smaller than any known bacteria at the time. Nowadays, we've actually found things that small here on Earth that are terrestrial. But we're talking about things that are, 100 nanometers in size, very, very tiny stuff. And so how do you have life in a package that small?
Have you been down there to Antarctica?
No, I would love to go. Ages ago when I was getting out of grad school, I actually entertained an offer to do a winter over down there. But ended up with a different job, which is too bad because that would have been a ton of fun. The first thing they do when the last plane flies out for the winter is they all sit down and watch a copy of The Thing, and that just sounds like a ton of fun.
Well, you said that you can just find rocks on the sheets of ice out there.
Mm-hmm.
Are the sheets of ice really dense, so when the rocks fall from the sky, they don't get buried in the snow?
Nope, they just land right on top. And a lot of the rocks are, a lot of the meteorites are fairly small, kind of pea-sized. Mm-hmm. This particular one was actually a pretty good size for the Alvin Hills one. I think was on the order of a few pounds. But yeah, they're just right there, and so this makes for a very robust way to go out and collect meteorites.
What is the mineral in the rocks that gives Mars its red color?
The red color is chiefly iron. And so the iron has basically bonded with the rocks as the planet evolved and the atmosphere leaked away. And so there's a ton of that, and that's the main source of the red color there.
Is it in the atmosphere as well? I mean, is it like possible that there's iron dust in the air that kind of gives it that red look?
There's certainly dust storms that come and go, and that can actually interfere with spacecraft operations. Ironically, there have been times where some of the solar-powered spacecraft or robots on Mars have actually gotten accumulations of dust on their solar panels, which when you get a storm blowing through that blows off the dust, it helps their operations. So that can actually be a help. But the atmosphere is primarily carbon dioxide.
Earlier you mentioned volcanoes. Is Mars still geologically active?
I believe you have some of that. And they do see with the orbiters, so there's a number of orbiters that are, going around the red planet and, mapping the surface over and over again. They do actually see things like things akin to landslides that happen from time to time. And so there are, it's not totally cold and dead. But this is one of the things that the planetary scientists that study Mars are trying to assess is exactly how active is it with things like that, or maybe volcanic activity. Trying to characterize what is still the internal energy, especially if you want to do investigations that connect to maybe if there's subsurface life. You do need some amount of energy input to sustain life of that nature, and so that's connected to that question.
Is there a way to measure from space if Mars has a liquid core like the Earth, like lava in the center that could erupt onto the surface?
So that kind of characterization of a planet is done by when you have spacecraft orbiting it. The nature of the orbit will get tweaked by, is it a solid core? Is it a liquid core? I know the Juno spacecraft that's orbiting Jupiter right now, one of the things that it has been trying to ascertain is, what is the nature of the interior of Jupiter, which is, again, its own difficult thing to do to figure out with especially a giant blobby gas planet like that.
Well, do you see this announcement and these potential biomarkers as a genuine breakthrough or more of an incremental progress?
I would view it more incrementally, even though, in today's 24/7 news cycle, I'm sure, it certainly had its splash. Mm-hmm. And the, new interim NASA director, Sean Duffy, certainly was not shy at all about describing how amazing this was, and how this rover, which happened to be launched under President Trump's first term, it was important for him to point out that this is NASA's commitment to conducting gold standard science, and and that is NASA's goal, is to do really high quality science. And I've seen this time and again throughout my career, actually, not just with this, that, or the other administration, of discoveries that are interesting and incremental, but maybe hyped a little much in the end.
Well, did it give you any inspiration at all with these findings?
Oh, well, of course. Yeah. I take a lot from this, because as a card-carrying scientist, I appreciate, how hard it is to do, even mundane things, and this is definitely not mundane. This is definitely a significant advance. But these things are hard fought victories in our quest to expand our knowledge of the cosmos, and so it's one of those sort of things that require a lot of grit and determination on the part of the it's a standing army that makes this sort of thing happen, between the scientists that are finally getting the data from the rover, but then all the engineers that built the rover, and the people that built the rocket that took the rover there. And, it's a really I think a testament to the innovation of our nation that we can do that kind of thing.
I guess we could say potentially this has got us one step closer to possibly finding life on Mars. For the record.
Absolutely. That's right. And it's very exciting in that regard. And it really, again, puts more wind in our sails of saying, okay, well, we've made this discovery, so now we really want to push ahead with, say, Mars sample return, the next mission that will then take these samples and bring them back to Earth. And that's really exciting stuff to think about, having something that will be the first thing to make the round trip between our two planets.
I think many scientists would say that the probability of Earth's situation being a habitable zone in a solar system is very, very unique. And some may say that we may be the only one out there. Would you agree with that?
Right now, we are engaged in this really grand adventure in astronomy to try and figure that out. And one of the things that I have seen over the course of my career is, you can estimate all sorts of probabilities as far as, what is the likelihood that a given star will have any planets, and what's the likelihood that these planets will be capable of hosting life, and then what is the likelihood that you actually do get life there. And the kind of the first element in those string of probabilities, do stars have planets, has actually, that isn't the thing we have answered over the course of the last 30 years with work that I have been a spectator for and also participated in somewhat. We actually know pretty definitively that stars have planets, that stars, the general tendency of stars is to have many planets around them. And we didn't actually, we thought that was the case, but we didn't actually definitively know that until, about 2010. And with results from spacecraft that were observing stars and trying to find planets around them, the Kepler spacecraft, the TESS spacecraft, we were able to definitively come up with that answer. And so the next steps are then coming up with the next parts of those, these probabilities. Are planets likely to be habitable? Are they actually then inhabited? And we're kind of well on our way to that second one of, for the stars that we do find planets around, do we find that they have some of their planets in the habitable zone? And we're finding planets like that. That's part of this reconnaissance we're doing right now in astronomy. And it's also been kind of exciting to chase that down. What's interesting about that is we have capabilities in the astronomy community to find planets, but we're really good at finding the big ones and the oddballs, the hot ones and things like that. And so the warm, habitable Earth-like planets are still very hard to see. And that's not because they're not there. It's just that they're the best at hiding. And so we're still pushing on that in the astronomical community, is trying to get better and better in finding Earth-like planets in Earth-like orbits.
Have the Mars rovers ever made it up to the polar caps, I guess up or down?
They have not. There was a lander that landed, I think, closer to the caps than had been done before, but none of the rovers have. The caps are interesting because they have a lot of ice, and for, say, future missions that have humans and want to use resources there, ice is useful stuff. Both carbon dioxide ice, but especially water ice, that can be used for oxygen, for rocket fuel, that kind of thing. But so far most of the stuff is been landed at the lower regions, and in fact, a kind of an interesting little wrinkle, an engineering wrinkle that people take into account when they think about putting rovers and spacecraft on Mars is that Mars has very little atmosphere left. But I've heard an engineer characterize it as it's enough that you can't ignore it, but it's so little that it's not useful. Which is to say, on the way in, you have to have a heat shield, and you can have parachutes slow you down, but a parachute isn't going to get you to the surface because it just doesn't catch enough air to loft you to the surface in a survivable way. And so this is why you see these things, these movies of, say, Perseverance landing where, there's a heat shield and there's parachutes, but then they cut those loose and there's this rocket sky crane. It's all pretty cool technology. But you have to use the rockets at the end because the parachute just won't, loft you down to the ground. And the parachutes themselves still are only just useful in the densest part of the atmosphere, which is, say, the equatorial regions. And so it's easier to land near the equator than the poles.
Is it possible that there are reservoirs of water subsurface?
The evidence that has come out of, like I was saying, some of these landslides that they've seen, it's thought that you can even have potentially water on the surface, which kind of defies the imagination, actually. But the explanation there is that if you take water, and so the thing that gets in the way is that Mars is very cold and very dry, and so you would think that any surface water would just freeze because it's well below zero. But apparently, if you get sufficiently briny water, so enough salt in the water, that lowers the freezing temperature, and you can still have maybe outflows that cause these landslides and that kind of thing. But the shorter answer there is yes. It's thought that there potentially is subsurface water of some form there.
If you melted all that ice, would you have some sort of atmosphere?
Maybe. People have talked about how could you somehow melt the ice at the poles, and how thick of an atmosphere would you get from that? Maybe the first problem there is how do you melt that?
Yeah.
Some people have adventurously suggested, well, we'll just use nukes because why not? Nukes.
Yeah.
And yeah, I think better answers, but they're not as immediate, and so it's maybe not as gratifying for people that want immediate results. Is if you could engineer some way of crashing comets into Mars, that would both warm it up, but it would also deliver a lot of, say, a lot of water ice there, and so you'd have a double benefit there of potentially giving it an atmosphere. That atmosphere would leak away again, but it actually takes, say, 50 million years for that to happen. And so on geologic timescales, this is why Mars looks the way it is. But on human timescales, if you could engineer that, then you would have a warmer, more wet, habitable planet once again.
Do you see any value in trying to habitate Mars like Elon Musk does?
I do. I think it's interesting. There were some interesting studies by Princeton physicist Gerard O'Neill back in the 70s and 80s, where the solution they came up with is that if you want to expand humanity into the cosmos, sticking humanity at the bottom of a gravity well like the Earth or like Mars is less good. And if you can actually come up with habitats that are just free floating in space, that that's if you're a spacefaring civilization, that makes more sense. And I happen to think that that's probably the right answer. There's a large number of engineering problems to be solved in terms of, humans are fragile things and don't do well in the space environment, and how do you come up with basically habitations for them that can help them survive and also are robust and can stand up to meteorites and micrometeorites and cosmic rays and solar flares and all the nasty stuff of the universe that's conspiring to kill us if we happen to leave the Earth and its rather protective magnetosphere that makes a lot of those things go away. But I think there are solutions there, and there's in the end there's always more people that will tell you that a thing can't be done than those that tell you that can before it actually happens. So I figure that is in our future.
I wonder if there are rocks on the surface of the ice sheets on Mars, just like Antarctica, and they're from other places.
Oh, there definitely will be. Yeah. The exchange of material between planets, if you invoke geologic timescales, is actually considerable. And it's led people to hypothesize with some speculative nature, but also in kind of an interesting way, that if you have transport of rocks between the planets, what happens if you have particularly hardy biological passengers on board as well, like bacteria or something. And so, this has led to people discussing things like panspermia. Maybe life originated on Mars, but then you happen to have a rock that made it from Mars to Earth with some bacteria on board, and that is where maybe life from Earth came. Maybe this is part of the grand adventure we're in right now, is to not only look for evidence of life on Mars, but if we find something like that, is it very similar to life here on Earth in a very telltale way? Maybe there is evidence that there was a common genesis like that.
You wrote a paper about putting telescopes on the moon, right?
Yes, yeah. That's kind of my new thing.
I think that's a great idea, and I wonder why we haven't put a base on the moon yet.
A big part of the question has been transport. We had a transportation system, the Saturn V and the associated things that took place in the 60s, and we walked away from it. And we've been stuck in low Earth orbit for a very long time as a result of that. And yesterday there was another test flight of the Starship launch system from SpaceX, which was pretty largely successful. And that is a interesting development as a potentially a tool that can be the new highway back up into more than just low Earth orbit. And so if we can do that, if we can start more regularly going back to the moon, then a lot of things open up. And it's been actually very exciting for me to watch this as kind of a longtime observer of the aerospace industry, to see how things have really kind of taken off in the last just 10 years, maybe 12, 15 years. And it looks like there is a lot more attention and a lot more investment that is going towards a sustainable return to the moon, where there will be kind of regular transportation back and forth to the moon, and a use of resources there where you can actually live off the land and become more self-sustaining. I always think of how the expansion into the West happened in the U.S. And initially San Francisco was a hostile, nasty place where you couldn't live for more than a week without external supplies. And eventually we built the Transcontinental Railroad and other ways to get there. And this actually opened up a whole part of our country that is now a self-sustaining part of and contributing part of the overall economy. And I think that that's going to happen as on a global sense, as the Earth connects itself to the moon and has more regular transportation between the Earth and the moon.
You're on X, right?
Yeah. My handle is Fringe Doctor for both that and Blue Sky. Mm-hmm. And, I don't have anything of great pontification going on there, but, it's fun to post stuff about things going on in space and discoveries and work that I'm working on. So, yeah, come find me.
Well, I'm sure you've probably seen the pictures of the artifacts on Mars, right? Mm-hmm. Every now and then somebody will post something that looks like bones or some structure that wouldn't naturally take these shapes, right? Have you ever seen anything on there that has, raised your eyebrows?
Not really, insofar that I come wandering around the deserts of the Southwest, see interesting stuff here and there. And, nature has a way of forming rocks and forming things that can be very unusual. I know humans do a very good job of projecting, things in their brain onto things they see around them. And, this is part of how we've evolved, and this is part of a survival mechanism, is being able to match patterns and being able to identify things, and sometimes incorrectly. Mm-hmm. So, if we find, a Sears and Roebuck hammer on the surface of Mars, then, if we can unequivocally identify that will raise questions. Yeah. But so far, we've things, you see things that look like a fork, and then, you drive the rover up to it and kind of look at it from another angle, and it's like, it's just kind of how it looks, and it's just a rock. So I think there are interesting questions about, can you find technosignatures when you go looking for them on the surfaces of planets, elsewhere in the solar system, even elsewhere in the universe. I was just at a workshop at Penn State University talking about the search for extraterrestrial intelligence, and the search for technosignatures like that is a real thing, and it could provide interesting answers on what the universe is like, and is it inhabited, and what are our neighbors like if they're out there. But so far there haven't been any things that have met pretty high standards of evidence yet.
Remember a decade or two ago, it was really popular to talk about the potential pyramids on Mars.
Yes.
What do you make of those?
As somebody who builds instruments for telescopes, I've found that very interesting results are often a problem with your instrument rather than being intrinsically interesting of themselves. In this case, those were very interesting results, but it really was a fact of, how these features on the surface of Mars matched the resolution of the camera that was taking pictures, and that subsequent photos have been at higher resolution and have shown that, they're not really kind of pyramids. They're just a rock formation that, when taken in through a certain kind of camera, happens to look like pyramids. And these pictures, show that, as they've gotten to higher resolution and they're maybe a little less sensational, suddenly the discussion about those things have kind of dropped off the radar. And I think it just highlights that, our desire to find something like this and see the pyramids on Mars, or that face on Mars that was there. Our desire to find something like that is really pretty overwhelming. We want to know if we're alone in the universe. And that has been a driving question in many quarters, and is a driving question with, say, more stodgy conventional science right now as well. It has deep scientific implications if we ever come up with a definitive answer for this, but also philosophical implications on, are we alone? If we find that there is life out there, it's going to say a lot about, was the universe made for us, or are we just bystanders on a bigger, grander scheme? I think in the end, we probably will find life out there, and probably sooner than you think, at least as far as finding simple life. I bet you we're going to find a lot of algae out there and this kind of thing. And I think that that's going to happen over the next 20 or 30 years with the sort of telescopes we can build that can look at planets around nearby stars and come up with signals of things that are pretty likely biosignatures, kind of circling back to that biosignatures. Just, I think we're going to find a lot of that. And it's going to say a couple of things. It's going to say that, we're not that terribly special because there's life out there. But it's also going to say we're pretty special because to find life, we're going to find that it happens in pretty unique places, and that our own home is really pretty special. And that, as we hold up this mirror to ourselves and, see this reflection of, what we are and what the rest of the universe is like, I think we're going to see that, it's we have this unique place, and we should take care of the Earth and take care of the human life on it and the rest of life on it. And I think that it's part of one of the things that really excites me about being a small piece of this grand astronomy adventure right now.
Have you used Google Mars?
I have not, actually.
Really?
I'm familiar with a few of these things. That there's a similar-ish sort of thing for the moon, which I've used a lot because I've been looking at sites for putting telescopes there and that kind of thing. But I know it's out there, and I've maybe toyed with it once or twice, but not anything significantly.
Well, what would be the benefit of putting a telescope on the moon versus having one in space?
The first step is, why leave the Earth? And the Earth has this atmosphere which helps us live, which is great, but it also is this turbulent, boiling medium that you have to look through. And so it's like trying to look at a coin at the bottom of a swimming pool. And it's kind of, it gets in the way. And so getting up above the Earth's atmosphere is what you want. We certainly have things like Hubble and James Webb that are orbital facilities, but they can be challenging to point and to keep oriented. There are things like reaction control wheels that basically change their spin so that they can act against the mass of the spacecraft, and you can spin things around that way to point. But for me in particular, the sort of telescopes I like to use are arrays of telescopes, where I use multiple small telescopes and I link them together to synthesize a single bigger telescope. And so here on the Earth's surface, we do that with telescopes that are, a couple inches across, maybe 40 inches across. And we spread them across the landscape, and you can effectively get a telescope that is the size of a football field or bigger. And this lets you look at things that are really minuscule. You're getting 100 times the zoom that you get from, say, Hubble. And yeah, you actually, from the surface of the Earth, you can beat the angular resolution, the amount of zoom that Hubble has. The catch is that because of the Earth's atmosphere, you have to take very, very fast pictures because of this boiling, turbulent medium that you're looking through. And so you can look at things that are very bright. And so you get this exquisite resolution on bright things, but nothing else. So you can go into space and think about putting one of these things in space where you have multiple telescopes, but then you have to orient things. And when you're here on the surface of the Earth, you can actually align things. You have to align things pretty carefully down to about the nanometer scale. A nanometer is, if you take your human hair, that's about 100 microns across. And you split that up 1,000 more times, that's about 100 nanometers. And so you have to do about 100 times better than even that. And so that is hard to do when things are just kind of wibbly wobbling around in orbit. And so the idea here is that if we could get to the surface of the moon and put our telescopes down, that they'll stay put. And that you can then do this synthetic large telescope work on things that are very, very faint. And this looks like this is actually a good idea, where with there being a increasing number of ways to get to the lunar surface with upcoming launches with spacecraft crews, with astronauts, or potentially robot landers, there may be ways to deliver a package like this to the surface. And because of the fact that there's no atmosphere, you can take a very long exposure. And so your individual telescopes that are contributing to the whole array can, in fact, be quite small because you can take a long exposure, and you can synthesize this very big telescope that's 100 meters across, bigger than a football field, with a small amount of hardware, and really come up with some revolutionary discoveries where you can look at distant galaxies and see, what they're put together like at the very cores, and see how black holes there are maybe gobbling up other black holes nearby each other, or even how the light itself from those distant galaxies is propagating through the universe and getting distorted by the granularity of space-time. These are all things that are possible with an array like that, which you just can't do from the ground.
Has the astronomy profession in general started using AI and applying it to their research? And if so, how is that working out?
Yes, the answer is yes. But it's in a surprisingly mundane way, which is, the most of my colleagues I know that are using it a lot are using it for coding, and using things like Claude.ai and ChatGPT and that sort of thing for coming up with software code that makes it easier to reduce your data, or to find details in the data that aren't there, or deal with very large data sets. And so it's not so much that AI is replacing the astronomers or coming up with creative ideas. You still need the human for that. But for things like snippets of either Python or C++ code or Fortran code, it's very, very useful for being able to, in plain English, describe a thing that, I want to take a file from this format and turn it into this format. It'll just, in a heartbeat, cough up a snippet of code that'll do that kind of thing for you. And so it makes you a lot more efficient, I find, with doing that kind of thing.
If we get back to the movie Contact, did that movie inspire a lot of people to become astronomers?
I think so. I think it was a generation just a bit younger than my own. That came out mid-90s, if I recall correctly. And so by that time, I was already in grad school and I was already doomed. But there are certainly many people that are for which that movie really resonated. and struck a nerve for them and sparked some creative imagination that kind of pulled them into the field. I actually I I like the movie, but I read the book first, and I thought the book was a lot better. But it's a matter of taste maybe on that front.
Have you ever been to the array near Socorro?
I have, yes, driven through it. That thing is amazing. The very large array, which is this array of, I think there are 27-meter radio dishes, of which there are 25 of them, and yeah, it's really amazing to see that, particularly when it's in a close pack configuration. That's the irony, is that when it's at its smallest is when it's most impressive, because you can see all these telescopes, these radio telescopes next to each other, and when it's actually at its greatest extent, because they can pick up these giant radio antennas that are each one of the individual telescopes of the array, and they can move them around with railroad cars. It's actually so spread out, it's actually hard to see them, because they're miles apart at that point.
I know this may not be your specialty, but since you're an astronomer, I have to ask.
Yeah.
What are your thoughts on 3i Atlas?
So 3i Atlas is this amazing thing that is coming through our solar system from interstellar space. It is a comet. It is unquestionably a comet. It is not anything else. There are people in the astronomy community who claim that there is a more technological origin of this thing. They tend to not read the literature and tend to have gone down a path that seems to lean towards the more sensational than the academic, I think. And the short answer is that if the community knew some kind of inside information about aliens or spacecraft or things out there, we would tell everybody, because it would double our funding. And we're also terrible at keeping secrets. And so, I think this 3i Atlas is really, really cool. And it portends actually a whole new area of inquiry over the next few years, because we have there's a new telescope coming online down in Chile called the Rubin Observatory, named after Vera Rubin. And this observatory is specifically geared towards not just mapping the entire sky, but doing so every 3 days, with the intent that you catch all the stuff that's blinking or moving or that kind of thing. And it's going to find a ton more of these objects that are part of the flow of material that's just passing through our solar system from outside the solar system, of just rocks and comets and extra stuff that happens to be in the spaces between the stars. And occasionally some of those things will pass through the solar system. And we're going to find a bunch more of those, and that's going to be great, because this is stuff from elsewhere that we can then, with different telescopes, then follow up on and do remote sensing on, and see what the composition of the rest of the universe looks like, what's the nature of the rest of the universe. We haven't had the ability to really directly sample small rocky bodies from other stars before now, and this will give us a chance to do that.
Why has there been so much hype about it? And people may be saying that there are so many things about it that are uncharacteristic of a comet.
One of my colleagues here in Flagstaff, who specifically studies comets, has done so for the last 40 years. One of the things that he tells me is how every comet is kind of its own snowflake, its own unique thing, and they all are a little different. And this one is maybe definitely on the edge of the envelope of what is different, but that's to be expected, since it's actually not of our solar system. It maybe has a bit more of certain kinds of molecules than you expect. It behaves in a slightly different way, but it's still in the bounds of what's normal. And this is what is kind of interesting about it, is just to see what stuff from outside our solar system looks like in that regard.
Supposedly the trajectory of it is something that has been said to be highly unlikely. Would you say that the trajectory is basically due to the gravitational pull of the sun?
it's debatable whether or not it actually is unlikely in the first place. Some people have claimed that it's coming suspiciously close to Mars or something like that. And an object coming through the solar system is going to come near to some planets and not near to other planets. Nobody's bringing up how it's not coming near to Venus at all. It's just one of those things. And the fact that it's coming close to Mars is kind of interesting in that we have this flotilla of spacecraft that are studying Mars, and they can, for the meantime, swing their cameras around and take a peek at 3i Atlas at the same time. So that's kind of neat. There actually is a mission that the European Space Agency is going to fly pretty soon called Comet Interceptor, where they're going to park a spacecraft at a spot where it can then easily rocket off and have a very close encounter with a comet of some kind that will be discovered actually after launch. They're just going to have this thing ready and waiting for when the next thing pops up. And what's interesting about that is that that could be used for a solar system comet is the most likely thing. But there are scenarios in which you have, again, another one of these interstellar comets coming from outside the solar system that presents itself on the right kind of orbit that you could intercept it and at least, zip past it and take close-up pictures of this thing from outside the solar system. And so that's actually really exciting to, have the ability and the possibility of much more closely looking at something like that and see, being able to maybe open up some sensors on this flyby spacecraft and directly sample the gases around it. And that'll be kind of cool.
It would be amazing if we could mount a probe on it.
Yes. So it's another thing entirely to zip past something and take a picture versus actually getting to it and then stopping and landing.
Yeah.
So it's a whole other level of energetics to do that. And that'll happen, but maybe not with this first mission.
In the UFO world,
Yeah.
there's a lot of talk about ETs being from the Pleiadian system.
Okay.
But I talked to another astronomer about it, and it's my understanding that that is a young star.
Yes.
And so there really isn't potential for life there. Is that true or not?
So the Pleiades are quite young. It's this star cluster that's, if you look up in the winter night sky, it's kind of near the constellation of Orion. And yeah, it's notable because it's a stellar nursery where very young stars are being born. There are some massive stars there that actually makes them really kind of pop out very nicely. And if you have a home telescope, you can very easily find this and look at this and see these stars closely next to each other, where these young large stars are lighting up the whole gas and dust nebula out of which smaller stars are forming too. But yeah, they're of an age of a few tens of millions of years. That is quite young. And here on Earth, the geologic record indicated that the sun formed and the planets probably formed within 10 to 100 million years of the sun actually starting to be a star, and that life here formed soon after that, but it was still millions of years after that. But complicated life took a very long time to get there. And so from those arguments, I would think that that'd be a bad place to go looking if you want to find ET. It's all projecting what we know from here as our reference frame, and maybe that's not valid. But the place I would go looking would be a much more of a middle-aged star or star system. The catch is that a cluster like the Pleiades, where you have a nursery that's forming stars, will, once it's done, after 200 million years, let's say, it'll drift apart. And so, in fact, our sun, if we want, you have to kind of go looking really hard to find out where are its birth mates. We've all kind of dispersed out into the galaxy. And to get to a star that's much more middle-aged, like the sun, where, at least with the example of the sun, we have some intelligent life here. You got to find something that's 4 billion years old or so, and it'll be pretty much all by itself.
I know we're totally speculating here, but is it possible that a migrating population could have moved there and found somewhere to be habitable?
It's possible, and in that scenario, which is, basis for probably really good sci-fi, that actually would be interesting in the sense that that area is very energetic with, these close clusters of young stars. In fact, dangerously so, in that there's a lot of ultraviolet radiation, there's a lot of X-ray radiation coming off of these young, hot, massive stars, which are the first things to light up in a cluster like that. So that could actually be problematic. But, in that scenario, if you have some kind of ability to migrate around like that, then you probably have an ability to deal with that. So that actually is interesting from that standpoint. But yeah, speculative, yeah.
Well, what's coming down the pipeline in space news?
Let's see. What's the next big thing? Well, the next big telescope that's going to go up is the Roman Space Telescope. And that'll be launching, I think, towards the end of next year. And what's really interesting about that telescope is that it's going to be the first large mission that will have a whole new way of looking for planets around stars. It's going to, previously there have been methods that have used, say, the transit detection method, where if you look at a star and the orbit of the planets around that star just happens to line up with our line of sight, you see a little dip in brightness every time the planet gets between us and its host. And so this eclipse method has been very successful for the last 15 years. What Roman is going to do is look for microlensing, where you have a star with planets around it, and our galaxy is this flowing river of stars all around each other. And if you look at a whole bunch of stars, and they then have stars behind them, gravity actually acts like a little lens. And the gravity of the foreground star, or even the foreground planets, will make that background star blip up in brightness. You actually go the other way. Rather than having a little dimming of the star, you have a little brightening of the star. And that tells us if there's an object there. So that's a way to detect planets. And what's actually really interesting about this is that first method with transits is very good at detecting planets that are close to the star. And so we have a very good census of planets close to the star. We don't have a very good census of planets that are far from the star, things like Neptune and Uranus in our own solar system. We don't really have a good accounting of what the likelihood is for planets to be in that area around a general survey of stars. Microlensing, this thing that Roman is going to do, is very good at that. And so we're going to be, more completely filling in the census of what we think planets are around stars, what the likelihood of planets are around stars. Is our own solar system an oddball or not, having big things far out? We just don't know right now from the data we do have. And so that's exciting, because that'll go up in a year or so, and then it'll, I think, start producing results pretty quickly. And we're just going to have this ever increasing number of planets we know about. And it's not just stamp collecting, but it'll actually give us insight on what the general, not just the general tendency of stars to have planets is, but what the general architecture is for stars to have planets. Is it small things, close thing, and big things out, far out, like us? Or is it something completely different? And that'll be interesting to more completely know what the landscape is out there, and where's the real estate.
Do you think we'll ever be able to create a telescope where we could look at planets millions of light years away and actually visually see the planet on screen?
I am happy you asked that question, because when I was at the SETI workshop in Penn State 2 months ago, I actually laid out what a telescope like that would look like if we wanted to see a planet around a nearby star, not just have like a blip of light that tells us, oh, there's a planet there, but actually see a disk. And, if there was a civilization there, do we see city lights on that disk?
That'd be awesome.
And it's not outside the realm of, well, certainly imagination on my part, but outside the realm of possibility. I think it's very, very big, but it potentially could be done if you learn how to, let's say, manufacture telescopes in space. The short answer there is it's going to be something like an array of telescopes. That's actually what I do, is arrays of telescopes. So I went down that path. Each individual telescope, you would have them be about a mile across. So it's big. So you'd have to mine an asteroid and then process that and make a mirror out of that in orbit. And then you would need maybe 20 of those, and they would be flying information at a separation of, let's say, 500 miles or so from each other. And this is actually something that doesn't violate any of the laws of physics. And what I find very interesting about that is the idea of manufacturing telescopes in space. If you can just start to do that with, say, small telescopes, if you can figure out how to 3D print a mirror that's 10 feet across, let's say, in space, that probably scales up pretty quickly. Once you can figure out how to do it at that size, the sorts of things that really complicate scaling up on the surface of the Earth they're not there. And that is to say, there's no gravity and there's no weather. And so you don't have to build a dome, and you don't have to have a huge structure that's supporting this ever increasingly large mirror. Once you figure out how to do a mirror that's 10 feet across, you can go to 100 feet or 1,000 feet across, and probably jump through far less hoops in scaling up than you would here on the surface of the Earth. And so that's what I find very interesting, is that it points us in that direction of something we're probably going to do anyway. There's probably many people that want to use telescopes like that to look down rather than look up, but fair enough. As long as you have a customer, you'll get the technology development done, and then we can do astronomy with large telescopes as well. And so I think that this eventually probably will happen on pretty sooner than people think.
That's hopeful.
Yeah.
Well, if people want to find out more about what you're up to or your publications, where should they go?
So they should go to either Blue Sky or X with my handle there, Fringe Doctor. And then they can also just find my homepage, which is a homepage on GitHub. That's my first initial G and my last name Van Belle, G Van Belle. And that's .github.io.
If people have questions for you, would you take them on X?
Yeah, that'd be great.
All right, cool. Well, before we finish up, can you leave us with a last positive message?
A last positive message. So I think there are a lot of opportunities in astrophysics right now. I think there's a lot of benefits to the technologies that come out of it. You know, things like better mammograms or medical imaging, or the cell phone on the camera on your cell phone, you know, has elements of it rooted back in detector technology development for astronomy. And so I think that we're in an interesting juncture right now with public funding of science and especially astronomy right now. But I'm hopeful that we will continue to see the value in that and continue to see the benefit of that for everybody, and keep on leaning into sustaining that kind of work. And so that's maybe the main message of the time, I would say, right now.
Dr. Van Belle, thank you for your message, and thank you for being my guest.
Thank you for having me, Jeff. It's been a real pleasure.
Thanks for watching the JeffMara podcast. I really appreciate you. Another way to show support is through YouTube memberships. And if you do, there are loyalty badges and other perks depending on your level of membership. All you need to do is click the join button underneath the video to find out more. Thank you for your support.